Now, problem on page 26. We're graphing the solutions of 3x minus 2y is less than 4. So what I'm going to do is isolate the y. All right. So I'm going to subtract 3x from both sides. So negative 2y is less than negative 3x plus 4. I'm going to isolate, and the goal again is to isolate y, so I want to get rid of that negative 2. So I'll do that by dividing out the negative 2. I'll do it from each term along my entire inequality. And what happens when I divide an inequality by a negative number? Reverse the direction of the sign. So 3 over 2 x minus 2. Alright, so now it's just a matter of graphing it. So the solution, when I talk about the solution, is the shaded region. Alright, so as long as we come up with a shaded region, we'll have what we're looking for. So I'm going to plot the negative 2. I'm going to plot a slope of 3 over 2, so up 3 to the right 2, consistently. And then go the other way, following the same trend. And then if it's not clear that it's a dotted line, you can just kind of fill in the blanks there and make it a dotted line. Should not be solid because it's a greater than symbol. If it were greater than or equal, or less than or equal, it'd make it a solid line. But that's not the case here. All right, so I want to go above this line. All right, you can do it by testing the truth of the inequality, but generally, it's just easier to determine it visually. It's y, the solution of y is going to be above that dashed line for all the area that's above.
How do you know when it's dotted and not dotted?
If it's a greater than or less than symbol.
So if it's greater or less than, it's dotted.
Correct. Anything else is going to be solid. All right, so then I'm going to shade above. And again, you don't get bonus points for making your shading look better than this, so that's good enough. In terms of how the region scores things, they generally want to see some indication that you're calling this the solution area, although I think it's pretty obvious. They say that they don't think it's pretty obvious, so what I like to do is designate this as the solution S, and then just pop an S in here. It's an added layer that I think is completely, totally unnecessary, but that's just how it is. So it's kind of stupid that they asked us to do it anyway. So word problems. Marie sells tacos and burritos from a food truck at the farmer's market. She sells burritos for $3.50 each and tacos for $2 each. She hopes to earn at least $140 at the farmer's market this Saturday. Create a linear inequality that represents the solution to this problem. Let x equal the number of burritos that Marie sells, and let y equal the number of tacos that Marie sells. I love tacos. Oh, they were delightful. They were delightful. I had to wolf it down after school between ninth period and extra help just because I didn't have time during the day, so I was a little disappointed. But when it happened, it was glorious. All right. So x is the number of burritos. So $3.50 on the burritos. So 3.5 or 3.50. I like simplicity. And y is the number of tacos, so plus 2y. equal to $140. All right. We have a linear inequality, but we have to graph it. So it kind of makes sense to get it in terms of x. So solve for y in terms of x. So I'm going to solve by subtracting the 3.5x. So 2y is equal to negative 3.5x plus 140. Then I would divide out the 2 from each term across the board. Create a linear inequality. She wants to earn at least, sorry. That should have been a greater than or equal to symbol. Meh. That actually happens to me more frequently than... All right, so y greater than or equal to, what's negative 3.5 divided by 2? Negative 1.75 x plus 70. All right, so we have to graph that. That's the tricky aspect of these contextual situations, just meaning word problems. We have a 70 here. All the other problems have, for y-intercept, they have cleaner numbers. So we have to develop an appropriate scale for this. So we want to start thinking about what is the best way to graph this. We could, but there's actually, some more reasonable ways to go about it. All right, we have a y-intercept. We'll work with that. What do you think we ought to go by on the y-axis? Tens? Okay.
Tens.
10 sound reasonable. 10, 20, 30, 40, 50, 60, 70, and then we'll work from there. All right, and these are our y values. The y-axis is already labeled. Just be mindful of the fact that it may not always be labeled. On the regions, they're looking to see that things are properly labeled, and you could lose credit if you don't label it, but I labeled it for you here. All right. So I can plot my y-intercept. So that's fine. So rise over run is not going to be as helpful here as it was before, or at least not in the exact same way, because we have a decimal value. We could convert it to a fraction. It may not be the most convenient fraction in the world. All right. Now, we can use the question that they're giving, or they're asking us, to our advantage here. It says, is the point 20, 49.5 a solution to the inequality? So that's telling me that I need to go out to 20 at a minimum in terms of x. How many boxes do I have along the x-axis?
25.
I have 25?
Oh no, it's thinking that.
We have an even 20, right? So we have enough to get out to 20. So what we can actually do is figure out what y would be if x is equal to 20. So what I would do is I would take an equation, not the inequality, but the equation, y equals negative 1.75 x plus 70, and pop in a 20 for x.
Wait, isn't it what?
No, I'm saying I'm actually going to use an equation here, not an inequality.
Oh, okay.
Just the equation. I'm doing that on purpose.
I just
Shockingly.
I just took negative 1.75 and then did math for x, and then I just plotted.
And that can work. I'm showing you a way that will work all the time. All right.
Wait.
So what do we get if we run this calculation? You get 105?
Wait, why did you plug in 20 again?
Because they gave us a 20 here. $105 seems low.
What is it?
35.
Oh my god.
right, so looks like addition instead of subtraction happened there, but it was good stuff. All right, so what that's telling me is that we have a coordinate along this graph at the y value of 35. So along this line, we have the coordinate of 20 comma 35. So I can plot that. I'm going to zoom in, do an extreme close-up here. You don't have to label the x-axis because it's going by ones. So you could just leave that blank because it's assumed that it's going by ones unless you change it. But for your own benefit, you may want to put some values there. I'll put the 20 here just to make it clear what I'm working with. 35 would be halfway between 30 and 40. All right, so what I would do is connect the 2 points. I think I have a line draw tool here. This one. No. What's this? No, that's like cutting stuff. Maybe this one. Let me try it. Yeah, let me try that one. No, that didn't. Oh, it worked. Yay.
What the?
Okay.
Is
Learned
that
it.
the line?
That's the line.
Oh.
Now, I'm putting an arrow on one side only. What's my reasoning for that? Well, I start at 70, sure, but in terms of the x values.
It keeps going.
And it's more so, why am I not putting the arrow on the 70? Would this line extend forever in that direction? No. What does x represent? Number of burritos. Can you have number of burritos be negative? No. Not easily anyway. The only way I can think of that would happen would be in a very disgusting fashion. Like you'd have to be giving back burritos in some fashion. And however that works biologically, I don't think that it is like not safe for discussion in class. That's somebody else's area of expertise. So I'm going to say that we can't have negative burritos, and if we could, we wouldn't want to have anything to do with that. All right. Same thing with tacos. Bless you. All right. So this is a way that you could graph a line without having to actually plot the slope. All you need when you're plotting a line are 2 points and a ruler. So if you have the y-intercept, you just need another coordinate. So choose a value of x that you want. Doesn't matter what you choose as long as it's convenient to the situation. I like 20 in this case because they were asking me about 20. It made sense, all right, to me anyway. But you might have said, okay, I'll put the number 10 in there and see what comes up, or 15, or 2. It doesn't matter. You get 2 points, pop a ruler on it. Now you have the general sense of what the line looks like, and then just go from there, all right? Because it is an inequality, we do have to shade. In this case, I'm shading what, above or below?
Above.
Above.
Yeah.
So I'm going to shade all this stuff. All right. So then the final question here would be, is the point 20 comma 49 and a half a solution to the inequality? Does 20, 49 and a half fall in the shaded area?
No.
So yes.
Yeah.
Explain your reasoning. Okay. Well, I kind of just gave it to you. So just kind of paraphrase or rephrase what I just said, assuming you were listening. Falls in the shaded area. If you plot the point 20 comma 49.5, it will fall in the shaded area.
Okay.